Hey there, in lesson 10.6, we're going to talk about special types of linear systems. Your objective is I will be able to identify the relationship between special types of linear systems. Remember, when you are identifying the relationship between special types or any type of linear systems, you are trying to figure out where do those two linear equations intersect. So let's start with concepts that we've talked about before. So in this one, a substitution, it's good to use substitution when one of the equations is already set equal to x or y. So if we see this one's already set equal to x. So we can go ahead and solve this by plugging in this whole value of what x equals in for x of the top equation. So we have 3 times 5y minus 4 minus 5y equals 8. Now we just have a multi-step equation. Sorry for my handwriting. So I'm going to go ahead and distributed property. So it's 15y minus 12. Bring down the minus 5y and the equals 8. Now I'm going to go ahead and combine like terms. So 15y minus 5y becomes 10y. Minus 12 equals 8. Now I just have a lovely two-step equation. I'm going to add 12 to both sides. I'm left with 10y equals 20. Divide by 10 on both sides. Oops, that's a 10. Y equals 2. So now we figured out what y is. Now we need to figure out what x is. So we're going to take what our y is and we're going to plug that into the bottom equation because it's already set equal to x. So we have x equals 5 times our y was 2. Minus 4. And then we just go ahead and solve order of operations. X equals 10 minus 4. X equals 6. So now we have what our y equals and what our x equals. And our answer for this systems is 6, 2. This is the location that these two linear equations cross. Now let's go ahead and talk about elimination. This was the next concept we talked about. Elimination is when something cancels. So notice right here, these x's can cancel out because 4x minus 4x cancels out. So we're left with negative 3y plus 5y is 2y equals 2 plus 6 is 8. Divide by 2, y equals 4. Now that we know what our y is, we can go ahead and solve for x by plugging in our y for any of the y's in the top equations. You can pick one, it does not matter. I'm going to use the top one. So 4x minus 3 times 4 equals 2. Go ahead and solve. So I have 4x minus 12 equals 2. Add 12 to both sides. I'm left with 4x equals 14. Divide by 4. We're going to go ahead and simplify that so it becomes x equals 7 halves. So there's my x value and my y value. So my solution for this system is 7 halves, 4. That is the coordinate point at which these two equations intersect. Next, you learned about graphing. Graphing is when you take your two coordinate points or your two equations and you plot them on a graph. You use graphing when both equations are set equal to y, and they're nice, and they have nice slopes, they have nice y-intercepts, and we can just go ahead and plot them nicely. So here, let's go ahead and plot this top one. Y equals negative 2x plus 1. We're going to start at our y-intercept. We're going to plot our y-intercept at 1. Then our slope is 2. Sorry, it's negative 2. So we're going to rise up 2, and we're going to run left 1 because it's negative. So we're going to rise up 2 and run left 1 because it's negative. We can also fall 2 for our negative movement. Run right 1. Remember, the key is just to keep it linear. Linear means a straight line. So there's our fancy line there. Now let's go ahead and graph the other one. So here's this. equation, y equals 1x minus 2. We're going to start our y-intercept right here at negative 2. And our slope is 1, so we're going to rise 1, run 1. Oh, and we can go ahead and stop right there, because that, ladies and gentlemen, is where these two lines intersect. Our solution for this system is 1, comma, negative 1. If they all were that easy, huh? Okay, now let's get into the special ones. This special type is when there's no solution. So what happens when there's no solution? If we look right here, let me zoom in on the situation. We're given two equations. Neither one of them simplify out. So we're going to go ahead and multiply this top one by negative 1. So we're left with negative 2x minus y equals 1. Okay. Now we're kind of ignoring that top equation. We're going to use these two equations now because I moved this one right there. Okay, so now if we look, 2x minus 2x cancels out. Positive y minus y cancels out. So on this left side of the equal sign, we're left with 0. We don't have any other terms. Bring that down, and we have 1, and that should be negative 5. So over here, we have 1 minus 5 is negative 4. Does 0 equal negative 4? I can hear you say no, it does not. So since these both canceled out, the y's canceled out, the x's canceled out, that means that this is no real solution, or no solution. Okay, that's one special. Another special is when we have many solutions. Many solutions. So let's look at this. Let's zoom in on this situation here. Let's see, we have, we need to cancel one out. So let's go ahead and multiply this top equation by a negative 2. So that we can make this a positive 4x, so the x's will cancel out first. So we'll go ahead and we'll get positive 4x minus 2y equals a negative 6. Okay, so now in this problem, we are working with these bottom two equations because we move this one down here by multiplying the top one by negative 2. Now we're going to go ahead and solve. So what we have here is negative 4x plus 4x cancels out, simplifies out. 2y, positive 2y minus 2y simplifies out. So on the left side, we're left with 0. Bring down our equals. Now we have 6 minus 6. That also equals 0. What do you notice? They both equal 0. Both sides simplify to 0. So since 0 does equal 0, that means that this linear system has many solutions. And what that means is that these two equations intersect at many points. That's it for our lesson for 10.6. Go ahead and try the Canvas problems. Let me know if you